So to begin with, take a look at this function on the interval from 0 to 1. So we don't have, at least my calculator doesn't have secant, so I have to use 1 plus 1 divided by cosine. And then for the window, have the x's range from 0 to 1. And then since this is 1 plus some more, have it go up to about 0 to 5. The graph itself is pretty boring. Just sort of an arc. So here's the x-axis 0 to 1, and then it starts at a height of 2, it goes up like this a little bit. So this is the region, and then take this region in here and rotate it about the x-axis, and you create some kind of volume. Something like a pedestal, I think it would be. Well, anyway, the interesting part is going to be volume is going to be integrate from 0 to 1 pi, and then the radius is squared times dx. Well, the radius is going to be from the axis of rotation to the function, so that's going to be the function itself. So it's going to be 1 plus secant of x. And then with this one, u substitution is not going to be helpful because we let u equal the inside part, and then the derivative of secant is secant times tangent, and there's no secant times tangent out here. So we need to instead do the algebra and multiply this out. So it's going to be integrate from 0 to 1. Oops. 0 to 1 all gone. Integrate from 0 to 1 pi, and then square this binomial. So it's going to be 1 squared. It's going to be this times this doubled, 2 secant of x, and then plus secant squared. Well, this one's good news because the antiderivative is just going to be an x. The derivative of tangent is secant squared, so the integral for this is going to be tangent, not a problem. But how do you integrate secant? Have you done that before? It's good fun. So let's get some scratch paper here. How do you integrate secant of x? So if you go through thinking about, well, the derivative of tangent is secant squared and things like that, the derivative of secant is secant tangent, none of them are exactly going to be just a secant by itself. So we need to either get this somehow turned into something with secant squared or something with a secant and a tangent. And it turns out that we use secant and tangent. So if you going to need a little more space. If you take this and view it as a fraction, then multiply the numerator and the denominator by secant of x plus tangent of x. And then if you multiply out the top, it's going to be secant squared plus secant of x times tangent of x. And the bottom, of course, is just secant of x plus tangent of x by itself. So you might say to yourself, where did you get that? Well, like I said, I know that the derivative of tangent is secant squared, and I know that the derivative of secant is secant times tangent, so if I could somehow get those things in there, then I know what their antiderivatives are. So I then used that to create these things. Okay, but the thing is we also have this denominator here. So what to do about that? Well, now this is going to become one big u substitution. Let u equal, and here it comes. So the derivative of secant is secant times tangent. The derivative of tangent is secant squared. So we essentially have whatever is in the denominator, we have the derivative of it in the numerator. And then the antiderivative of that is the natural log of u. So the u substitution is going to be let u equal secant of x plus tangent of x. The derivative of this is derivative of secant is secant times tangent plus the derivative of tangent is secant squared. And now you compare this with the numerator and it's exactly the same thing. So that means that we have du over u. And so then the answer is going to be the integral of secant of x is equal to, so when you integrate this, it becomes the natural log of u plus a constant. And then it's going to be the natural log of, here's the u, secant plus tangent. So the answer is going to be the natural log of secant of x plus tangent of x plus a c. So whenever you run across the integral of secant, you could either redo this work or you could just remember the integral of secant is the natural log of secant plus tangent. And personally, I don't find it too difficult only because what's the derivative of secant? Well, the derivative of secant is secant times tangent. And then what's the integral of secant? Well, it's also got the secant and the tangent, but it's the natural log of them added together. Okay, so now we take that and go back to this problem. So we've got a pi, this just becomes an x, then we've got 2 times the natural log of secant of x plus tangent of x, the antiderivative for the middle one there, and then this comes from the derivative of tangent. And then we don't need a plus c because we're going to substitute numbers in, a 0 and a 1. So 1 first of all. So the natural log of secant of 1 plus tangent of 1, and then a tangent of 1. And then minus, substitute a 0, so that's going to be 0, then we've got 2, the natural log secant of 0 plus tangent of 0 plus tangent of 0. Well, these, you've got to make sure that your calculator's in radians and just type that in. Tangent of 0 is 0, so this is actually gone and this is actually gone. Okay, so then make sure that the calculator is in radians, and we've got a pi times 1 plus 2, the natural log of secant, so that's going to be 1 divided by cosine of a 1, so that's that one right there, and then plus tangent of 1, and then close the parenthesis for natural log, so we're up to that right there, and then plus the tangent of 1, and they both have pi, so I might as well just leave this pi at the beginning, and then, or in other words, factor these pi's out to the beginning, and then we need this part. So 2, I forgot to say, subtract 2, the natural log of secant, so that's 1 divided by cosine of 0, which is actually 1, and the natural log of 1 is 0, so actually that's gone too. But we've already typed it, so grand total 15.739 cubic, whatever the units are.